Morning, everybody. This is your geography work for the week beginning the 4th of May. And we're continuing with the climate change topic. So the first thing I'd ask you all to be doing this week is making sure that your answers all go into your student copy of the climate change topic notes, which should have been returned to you after your last piece of work from the last 2 weeks. So the point we're up to this stage is that we have clearly established a link between changing planetary temperatures and changing greenhouse gas emissions, most especially carbon dioxide. And you've also now got an understanding of the evidence that we have that proves that the climate has changed in the past. And you've developed a bit of a skill in describing evidence and looking at graphs to pick out trends and seeing how things change over time. So that's where we're at. What we're now going to look at is actually what is causing these changes. And we've already touched on this last week, and you've developed quite a lot of understanding on this when you were studying this topic in National 5. And we're just going to build on that material. So if you still have your National 5 notes, you'll find that quite a lot of the content you developed when you were studying this topic back in third year is still highly relevant, and you can lean on some of those ideas. And all we're looking to do at higher is maybe strengthen the depth of detail you give. So let's have a look at the 5 tasks I've got you set for this week. It covers roughly the 6 or so lessons that you would have in geography this week. So I wouldn't necessarily think you have to do it all in one go, because it's quite a bit of work set, and you might decide to split it up into sort of 2 or 3 sessions. After I talk about each one in this little lesson today, you might want to pause the lesson video that I'm right now for you and complete each sort of task set. So the first one is to do with explaining the physical factors causing climate change. So I need you to find that section in your topic note set. And I need you to read that page to start with. And then I'd like you to answer the main exam question, which I'm indicating to you right there. So what are the physical causes? And this is a key exam question and would be, well, me and Mr. Anderson will be looking to mark it out of probably 6 or so marks. That is the kind of mark scale, or even possibly up to 8 marks that you would get. To answer this, you're going to need to open the that you will find in the task for this week, which has a range of video links to this particular task. I'm just waiting for it to open up. And you need to watch those video links and read the stuff resource sheet. Here we go. In order to answer the question. So here's a really nice little video explaining the eruption of Mount Pinatubo and the role of volcanoes play in climate change. And you've got a little bit of text there. And you then also have other physical causes like ocean currents, and you have the Earth's orbit, and specifically 3 aspects of the Earth's orbit: the wobble, the tilt, and the orbital changes. You have the sunspot and solar activity idea. And then lastly, one that we only touched on at National 5, and it's quite interesting because there's quite a lot going on plate tectonics and how they affect climate change. What we're asking you to do in the question, though, is to not just copy and paste material. We want to see it in your own words, and we want to see that you understand the work that you've been set. And there's some guidance in the topic notes set on how to write up each point. You don't want to write too much, because at the end of the day you have to learn this material, but you do want to make sure you are most specifically explaining what it is that you are doing. Okay, right. Once you've completed that, you're then going to be asked to think about the greenhouse effect itself. Okay? And we have another task sheet in the Google Classroom that we've given you, another higher resource sheet on the greenhouse effect. And I'm just going to show you that very quickly. And it's got a short video from the Met Office that talks you through the greenhouse effect, and it's got some other material on the greenhouse effect from the Met Office. And then we would just like you to answer the question on the greenhouse effect. It's just taking a little bit of time to load up. When you load it up yourself, there we are. There's the video, and there's material on the greenhouse effect. And I would just like you to read through that and go ahead and answer the exam question on the greenhouse effect. Okay, now that brings us to the third part of today's lesson, greenhouse gases and global warming. Okay, I'm just going to come out of the spotlight here and take you to the student note set on this. Now, this is you start to move into the fact that what you'll have established so far is that whilst physical factors do cause climate changes, they more often than not have very little influence, or as a matter of fact, they cause global cooling. And therefore, they don't really explain the current trend towards global warming. They do certainly explain ice ages, like the Milankovitch cycle and the Earth's orbit around the sun, are clearly an ice age factor. So that's a global cooling factor. But we need something that's going to start to explain what's going on with the warming we're seeing. So let me just scroll back here in your note set, where you're going to find here we go. It's just a bit slow today. Looking at the main greenhouse gases, and you've got a couple of pie charts. First, you'll notice is water is there. Water is a greenhouse gas, believe it or not. It's often not regarded as a greenhouse gas. Let me just scroll back down to that. Sorry about that. I wonder, as I'm doing this lesson today, how many of you are experiencing slow internets when you're trying to do your lessons and waiting for ages for things to upload. And I apologize for that. Technology can only be as good as the internet these days, can't it? Yeah, so here's a pie chart that shows the greenhouse gases. And actually, the most common greenhouse gas is water vapor. It makes up 95% of the greenhouse gas of the planet and plays a huge role in trapping heat. If you think about clouds, for example, they trap a huge amount of the Earth's heat. So what I'm going to ask you to do is read these couple of pages, ignore water vapor because there's nothing we can really do about the amount of water vapor in the atmosphere. But if we look at this other slim section of the greenhouse gases and we expand it out into a full 100%, we can see there's our big four culprits. We've got the F gases, nitrous oxide, methane, and carbon dioxide, which is by far the most. I've also given you a little bit of explanation here, which I'd like to read. Find out what GWP is. That's the global warming potential of a gas. And then start with the next page, which starts to look at the fact that carbon dioxide has been increasing substantially over the last recent period of time. And that graph's shown that. We were exploring this idea last week when we were looking at changes in carbon dioxide. Here we can also see that methane and nitrous oxide has risen recently. And most importantly, from this little source here, we get to see something that's really quite important. And it's the fact that whilst carbon dioxide is the most potent of the greenhouse gases, its global warming potential is only 1. So for 1 unit of carbon dioxide, methane is 21 times more potent in terms of warming the planet and lasts longer in the atmosphere. Carbon dioxide can last approximately around about 7 years or so at worst. It does vary. Methane lasts longer. Then we get up to nitrous oxide, which is, let me just bring on my spotlight here. We can see that it's got 206 times the global warming potential of carbon dioxide, which only has 1. So it's 206 times more potent than carbon dioxide. And to make matters worse, it can last up to 120 years. So even though there's a lot less nitrous oxide in the atmosphere and a lot less methane, they are far more powerful at warming the planet and they last longer. And then we get to the guilty ones, the F gases. Now, there is only a minuscule amount of them in the atmosphere, but as you can see here, depending on which one you look at, whether it's HFCs, PFCs, or SF6, their global warming potential is massive in comparison. So if we look at sulfur hexafluoride, it's 23 times more powerful than carbon dioxide, and it lasts roughly 3,200 years in the atmosphere before it dissipates. So if I just scroll down to the actual task, you're going to be asked to do. I'd like you to answer the task there. That looking at the evidence that supports the view, first of all, that the number of greenhouse gases has been increasing. So you need to give some evidence that backs the fact that that is happening, not just carbon dioxide evidence, but other evidence. And then I'd like you also to explore this idea that carbon dioxide isn't the only gas that's responsible for climate change, and actually talk about the other three and why, in some ways, they are even more concerning than carbon dioxide. Right, that brings us to the final two tasks. The first one is on, if I just go back to the main task sheet, is on the human causes of climate change. So you can see that down here, that explaining the human causes. You need to read. There are 3 pages. And I've got a little video I'd like you to watch, which talks about, sorry, I'm getting ahead of myself here. You need to read the page title explaining human causes. I've then got a resource sheet, just like I did for the physical factors. Can you find that in the Google Classroom? I'd like you to click on the links in that resource sheet to look at specifically methane, nitrous oxide, and the F-gases. You'll find in your student note set, I've already written up the 3 sort of key factors behind carbon dioxide, the most commonly discussed one, and I'd ask you to review what I've got in your note set on that. The thing I'd most likely to focus on are these 3 gases. So if I just show you the resource sheet there. It's just taking, once again, quite slow. There we go. So I've got a little video on carbon dioxide, which you can watch. It doesn't last very long, but it does talk about why carbon dioxide has changed over time. And it's a fascinating video, actually. It takes the change in carbon dioxide and links it to all kinds of other changes that are going on in human history, especially in the last couple hundred years. And it'll really give you a deeper understanding of how we became completely hooked on fossil fuels, especially as a planet. Then these 3 other resources on methane, on nitrous oxide and F-gases, short videos, and then you need to explain why the amount of methane across the planet. Obviously, we are looking at things like cows and rice farming. We are looking at the amount of waste we create that then decomposes and gives off methane gas. You can have a little look at your National 5 notes again if you wish, because there is some pretty good stuff on methane. For nitrous oxide, what we're really talking about with nitrous oxide is agriculture and the use of fertilizers that are nitrogen based. And the video deals with that. And than ever before, we've feed these extra people. That means more fertilizers and therefore more nitrous oxide. So you need to explain the idea. And then finally, this video here talks about the F-gases, identifies the kind of the 4 main sources of gases. And I'd also like you, when you write the F-gases, explain why is there more of it. So if we take, for example, air conditioning, which a coolant gas that is an F-gas in it, which cools the air in our homes, because populations are increasing in hotter regions of the world. If you think about the Middle East, like places like Dubai, more people need more air conditioning than before, and that means more of these F-gases need produced. So that would deal with the exam question. Have a look at how I want you to structure that exam question in the actual set. I've given you some guidance about how to approach it when I wrote up the 3 points for carbon dioxide, and I'd like you to add additional points for the other 3 gases. Right, that's an awful lot, but we've got one final area, which is the consequences. Now, I thought, how do I do this? Do I produce a big resource sheet? I thought, no, this is an area which you have a lot of information from National 5 that you could use in your National 5 notes. There's this really interesting news report that came out from a German media channel, which is actually in English, and it talks about the impacts in Africa and explores sort of 3 or 4 different effects that climate change is having in Africa in different ways, from the refugee crisis to droughts and food production, how it's affecting wildlife. You could pick up some really good ideas when you're wanting to write about the consequences, the global consequences of climate change. Your answer should always refer to actual specific examples when you're writing it up, and how, whatever the example you're giving, how people or the environment are affected. I've done one for you based on your reading from the first 3 pages, because you find I've got quite a bit on the consequences, specifically focusing on Florida and rising sea levels. And I've shown you how to sort of write up one consequence, and I'm asking you to do another 7. Even though it's a 10-mark question, not all your marks come from explaining a consequence, they actually also come from the examples that you give to support your points. Okay, so this will be a marked piece of work, as will be your explaining the human factors and explaining the physical factors. So 3 of these 5 tasks will actually have an exam mark given allocated to them. So spend a little bit of time on each of these. And I think each of these key ideas is roughly a lesson's worth of work, except this last one, which might take you just a little bit longer. Okay, so good luck. I look forward to reading your submissions. You'll get model answers to all the questions. So once you get your feedback, make sure you read the model answers and see how they compare to what you yourself wrote.